because whatever is on the left side of the equal sign is equal to what's on the right side. And most exercises that we do in mathematics and science is that we want to find what the value is at 0 or what the value is at 1. So this, for example, say if x represented a number, minus y, if this equals 0, there's more than one number for x and y that'll do that. For instance, 1 minus 1 equals 0, 2 minus 2 equals 0. We all remember that from kindergarten. Well, one of the powerful things that we need to do in mathematics is graph equations. Equal sign, equation. This is an equation. If we want to graph this, all we need to do is let one axis represent x, and then a height axis represent values of y. And we know if x equals 0, 0 minus 0 equals 0, so y must equal 0. Where these two intercept, we'll let represent 0x going this way and 0y going that way. Generally, since these are both to the first power, this equation graphs as a straight line. Now all we need to do is make a table of values for x and y and pick values to graph. So we already know if x equals 0, y equals 0. That's 1 point. So if we want to pick another value for x could be 1. So if x equals 1, 1 minus what equals 0? 1 minus 1. So y must equal 1. In order to graph this, we come over 1 for x, we come up 1 for y. Put a point there. Our next, say 2. If x equals 2, 2 minus 2 equals 0. So if x equals 2, y equals 2. Now with these 3 points, we can now determine a straight line through those. And this tells us that just about any value of x we want to pick is going to have an equal number for y. This is a very popular equation because we can rewrite this. Instead of x minus y equals 0, if we added a y to both sides of this equation, we would get x minus y plus y is 0. So this would be x equals 0 plus y is simply y. This equation should be committed to memory. X equals y is a straight line. And now in the negative region, a straight line. Thus any negative value of x will give it a corresponding equal negative value of y. Again, first powers create straight lines. So when does this get more complicated? Well, when equations come to different powers. What if we say x squared equals y? Now in order to graph it, it's going to be each corresponding value of x is going to have the squared value of y. So the easiest ones we pick are 0. If x is 0, 0 squared is 0, so y equals 0. We're still at our point here. If x equals 1, well, 1 squared is still only 1. So what we find, 1 equals y, 1 to 1. Now this is where we could think, oh, it's going to form a straight line, but this is why we need our third point. Because now if x equals 2, 2 squared is 2 times 2. 2 means whatever the x value is, 2 times that self again. 2 times 2 is now 4. So if x equals 2, y equals 4. What we see is now when we just come over 2 places for x, we go up 4 places for y. The same now for x equals 3. 3 squared is 3 times 3 is 9. This is a curve. Squared equations, also known as functions at times, produce curves. Commit this equation to memory, because this is only the positive portion of the x-axis, positive portion of y-axis. Squared numbers are always positive, so y, if we take a negative 2 times a negative 2 is a positive 4. So another value here would be negative 2 for x, that was 9, is a positive 4 again. So negative 2 units for x, and we're right up here again. Negative 3 times negative 3 is positive 9. We're up here again. This is a curve. X squared functions are always positive y values, and they're curved because of the square. Next, I'll show you a cubed function, which will look non-intimidating. The cube is three-dimensional. Well, 3D turns out to be from the third exponent. X to the third is what's called x cubed. So if we say x cubed equals y, what we need to do in order to graph it is make a table that for each x that we pick, the corresponding y value will be calculated in order to graph it. X-axis side to side, y-axis up and down. So now, x times 0, again, is 0. Those are always easy ones. Another easy one is 1. 1 to the third, again, is 1. So y is 1. So we have 2 of 3 points already. You see here, could mistakenly, again, lead us to think it's a straight line, but we know, because we have an exponent greater, it's just not 1, so it's going to be a curve. As I'll show, we can have fractional exponents. They're curves also. But in order to graph this now, we need a third point and probably more. So if we pick x equals 2, now 2 cubed is 2 times 2 times 2. It's x 3 times itself. X times x times x. So for 2, it's 2 times 2 times 2, which is 2 times 2 is 4, times 2 is 8. This is when you hear an equation is growing exponentially. Exponentially now means that these aren't one-to-one correspondences anymore, because we've gone over 2 units for x, and already on y, we're at number 8. So curve. Now we'll choose a value to determine what's happening on this side of the x-axis. So let's choose, say, negative 2. Well now, since it's an odd number power, before negatives times a negative made a positive, but now a third times a negative is going to bring it negative again. So negative 2, it's written negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is positive 4 times negative 2 is a negative 8.